Hello everyone. So today we are going to cover a topic from calculus. So basically what we are going to cover today is gradient versus derivative. We are going to study the physical importance of both of them and the difference between both of them. All right. So let's get started without any further ado. So a derivative to a function basically tells us about the rate of change of that function, right? It tells us about the rate of change of that function uh, with respect to a certain basis vector. So it could be x-axis or y-axis or anything. It depends on how you're mapping your function, but it basically tells you about the rate of change of a function, right? It tells you about the tangent of a function. We usually say that tan theta is the slope of line, right? So when you derive something, you get the tangent to a curve at that point. So it basically tells you about the rate of change of any function. Now moving on to a gradient. Mathematically, a gradient, all it means is nothing but partial derivatives, right? Let's take up an example. So negative E, where electric field is signified by E, is equals to the gradient of V with respect to uh, R, right? R is R has three basis vectors x, y, z with I, j, and k cap, right? These are x, y, z basis vectors. So how we mathematically write it is we write it as del v upon del x I cap plus del v upon del y j cap plus del v upon del z k cap. This is how it is mathematically written. If you want to know its linear algebra expression, then I can show it to you in the next class. But right now we are only covering basic algebra. So this is how it is denoted as, right? This is how it is denoted as, where the basis vectors are basically I cap, j cap, and k cap. So what a gradient gives you in terms of definition wise is the fastest way to bring change for the steepest path to get up, right? It gives you the fastest path to get up, the steepest path to get up, right? Up on a graph, right? So now you have to imagine that electric field is the negative of the steepest path for this function, right? So if we were to imagine it, it had the nature to go up, right, as quickly as possible. So now what we can get by its definition is the fastest way to get down, right, or the negative of the fastest way to get up is electric field. Now we already know that in electric fields, right, this is an electric field. So what happens is potential, the charge is moved from higher potential to lower potential, right? As the radius increases or as we move along the electric field, the potential also decreases, right? This is what we are already aware of. Let's consider this a uniform field. Then these are equipotential surfaces where this is higher and this is lower. As you move along electric field, the potential decreases. So electric field is giving you the steepest way of decrease in potential, right? That is what we understand by its definition. And the way we can calculate it, let's say we have the expression v is given by 2x square, right, in some fairyland. Let's just say There is some example where it is given by that. Now, figure out E. Right. All you're told is figure out E vector. Sorry, did I not write vectors here? So, by definition, gradient is the derivative, the partial derivatives of a scalar field with respect to vectors, right? Vectorial derivatives. It gives you a vector as output. So let me give you a short overview. So there is one thing named as curl. So what curl does is it gives you vectorial field upon vectorial field. It is that kind of derivative. We are not going to discuss it today. Then there is gradient. So what gradient does is it gives you scalar upon vector, and the output is a vector. And then there is the total derivation, the total derivative, or the basic derivative as you call it. So it could be it is usually the denominator is usually a scalar quantity in that. So what ends up happening is the output that you get is also scalar, right? That is what ends up happening. Now, if we were to try to figure out E using this expression, then what we can do is we just derive it with respect to x. So with respect to x, what it becomes is, okay, 4x. Right, this is, if I'm not wrong, 4x is what it becomes. 4x I cap plus 0 j cap plus 0 k cap. So what ends up happening here is when we are deriving it, partial derivatives basically mean that we ignore all other variables, or we consider them basically a constant, right? We are considering them a constant. So for example, if we were to calculate the partial derivative of this with respect to x, then it would be something like this, right? Because we consider it a constant in this scenario. So I think it helped you with calculus somehow. So if you like the lecture, just make sure you subscribe and leave a comment down below if you have any doubts. Well, I think this is it for today. Thank you.